usuals. So fourth week, uh, almost halfway done. By the end of tomorrow, we'll be halfway done through this. So what we'll be typically discussing is we'll be discussing social networks. So has to be one of the hottest thing out there. Most challenging with respect to engineering problems, the way those problems are addressed at scale, everything breaks, all kinds of theoretical limits that we see, or all kind of theoretical problems that we see. Everything appears when you go at scale of a social network, right? In general, when we, there are some rules around doing a good system design. Like it's not about knowing a lot of stuff. It's just about having that particular natural progression towards doing it. For example, in the past couple of weeks, when we were designing systems, we always went for what we started very small, and then we started to add more and more complexities towards it. Right? So when we do that, always, whenever you're designing any system, try to step scale. Don't directly jump to like a million requests per second, because it's very hard to comprehend what kind of problem would that even be, like what could have happened there. Because once you have this sort of natural progression towards solving a problem, life becomes much simpler. You would design really great systems when you try to do that. Last week, me and Sarthak were actually discussing something. So Sarthak opted for a mentorship call, so we went on a call, and we were designing stock market car system, like doing the buy and sell. How would you design it? Obviously, there are a couple of videos available on the internet, but the way, when me and Sarthak were discussing it, the way we designed was very different from what was actually available on the internet, because the way we approached the problem was very different versus how people might have solved it. But then when we were dissecting it, right, so what we would do it is, so I'll just share the architecture diagram, the one that we finalized upon, to just have for you guys to actually take a look and see, and then basically try to reverse engineer it and see the kind of decisions that we had to make. So Sarthak, you're going to share that diagram now. If you can just share it with me, I'll just, or if you can like directly post that diagram, only that architecture diagram, the one that we do at the इसमें,
Sure,
उसको
sure.
अगर तुम
I'll
post कर दो, because there are lots of nuances. I would just want to see how many of us can actually try to decode every single design decision that we made along the course. Okay. तो उसपे बहुत interesting चीजें discuss हुई थी, like the way in general it's available versus the way we designed it was quite different. So it was something really interesting discussion that we had last week. Yeah. Then second point is no premature optimization. This is a big killer. Matlab, when we have premature optimizations, what happens is, again, we try to optimize for something that is still not a problem, right? So basically, first and second point are correlated. So whenever you're designing something, just think of the next immediate problem that might be there, and just address that. This goes for when you are working in a startup or when you're starting up. That's where this is of highest impact. But even when you are discussing it during interviews or discussing it at your workplace, never jump, or basically never skip a step. Like never do premature optimization unless you are like really sure that this is going to be the the pain point going forward. Like unless you're pretty sure about it, never jump to that part. And every single component could and would fail, similar to Akamai. Like DNS is always a problem, once in a lifetime sort of issue. But every single component could fail, would fail. Assume that and see how you can try to fix it. So this is typically high availability and disaster recovery strategy, HADR strategy. So you can think of it like every single component you have, how if that is a single component, that becomes a single point of failure, how to avoid that. Then if if my region goes down, do I have another availability zone on which I can rely? If it's there, theoretically it is very easy to add another dabba. But what matters is how do you exactly implement that? Assume you are cloud native on AWS GCP and just Google just one thing, type how to do high availability configuration on your cloud and have that answer ready. Because this is what the difference is. Most people just draw the dabba ki another availability zone. But when we ask how do you exactly do that, no one really has an answer, because it is not as simple as it sounds. Cloud has made it pretty simple, But having those kind of database configuration into multiple region might be a multi-master setup that's extremely complicated to manage. So all of those things is something that you should know about. It's just about scratching the surface, or basically shining the light on the surface is everyone does. Ke another availability is on. I just watched a couple of videos on YouTube, like they just added a box, ki, acha, another availability zone pe dal denge. But no one discusses how, which is what is the difference between a good engineer and a great engineer, right? So knowing that one detail would make you shine, right? Be at work, be in interview, be at any place. So always keep a knack of not just shining the surface, but actually scratching the surface, digging deep, and just understanding and answering every single question that you might have in your head, because internet has answers to every single thing. So go for that. Don't just like see the surface, right? So what we'll be doing is we'll be dissecting Instagram. So Instagram में features like photo uploads, messaging, hashtags, reactions, following, search discovery. So all of these things that you see, each and every above feature is a big system in its basically on its own. Like if you see, it would not be just one machine doing that job. It would require a lot of input streams, output streams, maybe an event bus, a lot of complex architecture, maybe a CPU intensive job and whatnot. Like with respect to notifications, you might have all seen my video, like how interesting it is to scale a notification system, right? So and how would you actually do that? So once you think on that lines, every single thing, every single of the above feature for us, for an end user, like for you and me in general, it looks like a feature. But for an engineer at Instagram, this is a massive system which has to operate at scale. Like how will you ensure fault tolerance, robustness, ensuring that there is no data loss or no packet miss, or no asynchronous job being missed, or not a case where a cron job is not triggered. Like so many complexities might come in there. So given that, what we'll do is we will try to dissect most of them, but in general, you'd have an idea about all of them by the end of this week. So if not this, then by the end of IR week, definitely. So why we picked Instagram? Just out of the box, because everyone is used to that. But every single social, if you see, every single one of this feature is present in every single of the social network that is there. Like be it Instagram, Facebook, Twitter, LinkedIn, it just comes in a little different flavor. So all social networks are designed and scaled in a very similar fashion, and not just social networks, but a lot of other systems. So we are just taking Instagram as an example, but all the features and decisions remain fairly similar for every single network, every single social network out there. Right? Just remember that it's not just specific to Instagram, but you have to build that acumen key. Okay, this is a kind of design pattern that I've seen. Basically, in to put it simply, it's a new high-level design pattern that I've seen, and this is how we have made all of these decisions. Where else can I apply it? So, what you again, similar to last week, what you should be grasping is the design patterns, like answering those whys. Why did we choose A over B? Why did we or if we would want to implement something which is right heavy, what did we do? Like understand those patterns. Answers definitely won't be there. Okay, this is a system, this is the answer. Because once we are good with the building blocks, life becomes much simpler, because you can design any system out there with ease. So the designs that we discuss will not just apply to Instagram. So understanding the semantics is more important, not just limiting to uh, social networks in general. If you understand the semantics and the design patterns, you can build a ton of other systems around this. We'll be covering a lot of fancy stuff here anyways. So Instagram's tech stack, this is magic. 1 year, 14 million users, 3 engineers. Like just imagine those 3 engineers working for like 1 year, and they garnered like 14 million users. And this was their tech stack. That is it. Nginx, Django, Celery, Postgres was the primary server. Caching for that, they used Memcached. They had Cassandra as another database to store photos and all. Then they used Redis for some use cases, and they had a RabbitMQ, which acted as a message broker. That is it. These were the moving parts that Instagram had at the end of 1 year, when they had 14 million users and just 3 engineers. Like this is what is amazing about it. Like this is the most simple day zero tech stack that you will ever see. Matlab, and matlab, I worked at Fracto at that time. We had a very similar tech stack. Unacademy for the most of the part had this very similar tech stack until we became $1 billion. That's when we started moving out of this thing and started building other stuff. But till then we had a very similar stuff. Matlab, we इसमें से we just remove matlab, just replace Postgres with MySQL, RabbitMQ with Redis, and just get rid of Cassandra. This was the exact architecture of Unacademy when we were $500 million company. One monolith to serve everything. And then after $1 billion, we reached $1 billion, and that's when we decided, chalo, let's create another microservice because one service, one monolith service would not serve us good because the number of engineers were growing really high. So इसलिए फिर we moved out. But if you see, this is a very classical day zero tech stack for any company out there to which boosts developer productivity by introducing Python as the core backend language and just using every single moving part here, which is like very strong ecosystem of Python, Nginx, Django, Celery, RabbitMQ, Redis. Instead of Postgres, pick MySQL if you're comfortable with that, and maybe Cassandra or Redis as a cache, something like that. Like nothing fancy, but Instagram, due to their solid product, 14 million users in just 1 year. Just amazing. Like 3 engineers are pulling this much off. So what did they do? They use Postgres because it gives you ACID. They use Cassandra because it was distributed and scalable, but they did not use any managed system for that. They managed this database on EC2 instances because when Instagram launched, AWS did not have database as their offering. So they manage these databases on EC2 instances, not even using a managed service for that. But now we are fortunate to have managed service. So just use out of the box managed services to do that stuff. The entire storage layer works upon the assumption that there will be delay. This is something that they lived by. That is okay. That because if they assumed this part, this means that if every single thing assumes that there will be delay or there will be eventual consistency in the system, what would happen is they always ensured or their code always ensured the case when my data would be null or some attribute is not filled. All of those cases they assumed when building. So which means that they were very heavily asynchronous from day one. Something which acts as a golden rule, that something that does not need to be real time should not be done in real time. And that is how you scale. So everything that could become asynchronous, make it asynchronous. So they did it very heavily. And they worked on this assumption. Another company that works on a very simple assumption is LinkedIn. LinkedIn still has a lot of data mismatches. Like in one of the tabs, it shows me count of 3, but the number of rows are just 2. So it just has this thing because it assumes delay to be there. It assumes data might be a little incorrect here and there because like since it is asynchronous, you cannot guarantee that everything would be just a transaction. Like you made an entry and then deleted something, flowing it back to the main source of truth. It does not always happen. So most of the systems are built with some constraints being relaxed. It's something that you would have to take a call on. What are the strict non-optional constraints that you need when you're building a system? And what are some optional constraints that you might just have it a little lenience on? कि मतलब, chill nahi hua, that's also fine. So you'd also, depending on that, you would make some great design choices. So for Postgres, what they had was they had one master and obviously the classical multi-master setup and master replica setup. So they had master, they had one master and multiple read replicas. Replicas were across regions, but master was just one. So cross region writes were really expensive. So writes, let's say the server is hosted on in India, the write happening from the US would fly to India. So the database transaction would happen like from US to India, but there would be some cross region read replicas as well. So the master would be there in just one region and the replicas could be spread across geography. This is how they ensure that reads are much faster than writes, and they just had one writes, and then eventually they went into multi-master mode. And their web and application, so their everything, every single API of there was stateless, workers were stateless, which means that they could very easily horizontally scale without any hiccup. So Web and workers are all stateless. Asynchronous jobs like through web servers and Celery and stuff, they used to do this. For folks who don't know, Celery is like Sidekick in Ruby, or something to that makes life simpler to do asynchronous processing. Just look out for it on internet. So Celery. Sure. Now this was overview of Instagram when they were 1 year old. Now what we'll do is we'll start dissecting things and start building feature upon feature upon feature and see how can we make decisions around it. So before we move forward, any questions? Nice. Sure. Nice. So what do we do? Again, typically we start with database model. Like there are some great design decisions that we have to make when we design a database like this. A bunch of this are covered in the first week, but it is important to reiterate those to, because if we don't make those decisions, your overall database design falters very easily. Right. So we'll go through it. Users table, you would have a primary key, ID, integer, a unique key on email, a unique key on username. So email, username, both varchar, and you have ID, and then you would add some details like first name, last name, and whatnot. Right. So we did not make username as a primary key. Why? Question.
Touching on integers is actually pretty fast. I mean, index memory usage.
Mhm. Good. So primary key being integer, and also one more point is there that Instagram allows us to change the username, because if this request comes up, then if you have username as the primary key, you cannot change the primary key, right? Because that would act as a foreign key at a lot of places, right? Apart, so even if you would have something like this, since one of the feature or one of the requirement of Instagram was that username has to be editable, so this made sense for them to have this part where username is just a unique key and not a primary key. But along with this, keeping index lean and small, ID being stored in indexes makes that thing faster. Integer lookups are much faster than string lookups. Email being unique key, obviously, to find if email is already registered and only one user should be there, so that this ensures uniqueness, because you cannot rely on username to be the unique, because people can like change it now and then, but email is something that is not changing. Then comes another table called photos, because Instagram pay you upload photos. So photos pay you would have one primary key ID, which is the photo ID. Then you have a foreign key on user ID, which says that who uploaded this photo. So uh, who is the author of this photo. Then you would have a URL, right? So for URL, it's a type varchar. Do we need a unique key on URL?
No,
Why?
I mean, same photo can be uploaded by multiple users.
So
So,
would you give same URL to multiple photos uploaded to the same photo uploaded by multiple users?
I mean, same user can upload multiple photos. So, I mean, okay, you are asking, okay, if two persons upload the same photo, if we,
That's what you
I
said. That's
don't,
what you said. That's what you
I
said.
mean, we can't actually give it because we
Hmm.
can't compare. I mean, maybe we
Hmm.
can identify hash and do something,
Hmm. But would you want to do it?
yeah, no.
Why?
Because comparison of photos is very
Let's
difficult.
say you have hash. Would you still do it?
That's a privacy concern, right? Or in the backend, like you are kind of,
Hmm.
because WhatsApp also does that, but since it's stored locally, I think that because if you have of the same multiple media, it points to the same kind of, I think,
Hmm.
object.
No, no. But would you do it? Let's say you are CEO of Instagram and you would want to take a call. And obviously you're the first engineer there. So now tell me, would you have a unique
No,
key on URL?
because you already have a lot of photos, so who cares if there are some repeated photos?
Exactly. Storage, cloud storage, blob storage, S3 is the cheapest thing on the internet. Right? Don't worry about that. You would anyway have millions of photos. Having even 5% of it redundant will not make a lot of difference in the cost, because S3 cost is anyway very cheap, right? Also, if you do that, if you add that additional check key hash nikal ke, you would change and check if that is there. That's too much of processing going on CPU cycles just to save this much of money. That's not worth the call. Like if you would have done this, this would have been a classical case of premature optimization. Like you don't want to optimize on that, right? So don't worry about something. And yet one more reason, one more big reason with respect to database performance. If you keep a unique key on that, whenever you're uploading a photo, every single index, whenever a row is updated or created, all the related indexes that happens are right. So if you create a unique index on URL, are you even, or basically will you even make a query on that? Are you searching a photo by a URL? Typically never, right? Since you're not searching photo by URL, why would you want to waste your disk space of your database by creating a unique index on URL? Right. So with respect to database constraints, also you should not be creating a unique index, although it tempts you, like your URL should be unique, but not everything that has to be unique should be having a unique key constraint on the database. Right. So this is something that you should be always keeping in mind. This is not just limited to URL, but a lot of things that you think is unique. So an equivalent of this is blog title on Medium. Let's say you're designing Medium. You have a table of articles. On that, you see a column called title. You would be tempted to have key. I should not be having repeated item. I should not be having repeated blocks. So let me keep a unique key on title. But does Medium do that? No, because two articles might have the same title, but they have different ID because they are uploaded by different users. So you are tempted to have a unique key constraint on title, but that is not always a good option. Right. So there are lots of similar examples. Like while designing a database, always keep in mind, like ask this question: would you need, or would you be ever querying a row on this thing? And let's say you don't have an answer about that on day one, right? So don't prematurely create index on the database. Once that requirement pops up, then you go ahead and create an index on that. Because if you do it pehle se, then you are immediately succumbing ki your disk usage might shoot up, or your database might see a lower performance, and all that would happen from day one. Versus when and it might happen that your index that you created on day one, which is you thought that it would be used, but it is never used, and then it is just there, just sitting on the disk, consuming the disk space, because all the writes happening is also going there. Your write performance is affecting, and you and other developers totally forget that you have created an index which is not used actively. Right. So given such things, do not do premature optimization. Do not pre-thought. Basically, do not pre-think about what would happen. Just go by that nature. Like, and this goes for every single database design that would be doing. Okay. Then what do we have? We have index on created at begin and some text. So we would have another column called created at, because like we might want to to render the profile page of a user in which we show photos in descending order of time, we would need a created at. Even if not, we would still need to show how old a photo is published. Like earlier, Instagram used to do that, but then it removed that option, how old this photo is, because why to even show that additional information? Because people would think Instagram is suggesting older stuff, so they don't typically show that. Earlier, they used to do that, and you'd need an index on that to make those queries faster. Because when you're fetching it needs to be accessed through this, because you'd be doing order by created at descending. And when you do that, if you do not have an index on that, it would do a file sort on the entire table structure on, or rather user ID by file sort, and then it would sort it and basically get it with respect to descending order of created at. If you have that index, then it would already have a mapping of created at in descending order and user ID. So then you would be like very easily be able to have the profile page of the user rendered. Text is varchar, which is like the caption of the photo. And then the index on user ID created at, and this is what I was talking about. So this, the final index, this one is a very critical one, because this index is a composite index which is based on user ID and created at. This index is very important because this index is solely going to be used to render the profile page of a user. Like जिसमें you would see like all the photos in descending order of time. If you don't have this index, what would have happened is you would do you'd fire a select query like select photo ID comma something, or basically photo ID, photo URL and other details from photos where user ID is this, order by created at descending. Let's say you don't have this index, but you would have a foreign key index on this thing, user ID. So you would anyway have index around that user ID and some primary key to this thing. But then when you say order by created at, it would not find any relevant index. So it would use the first index, use the table, then foreign key and this primary key ka table ka location. It would get all the rows in memory and then do an external sort on disk. If it's too large, it would do an external sort. If it can fit in the memory, it would do quick sort and get all the information, load it and then sort it with respect to created, which is a very expensive operation. To mitigate that, since opening up a profile of a user is a frequent operation, you should be having an index on user ID comma created at where even order is important. Like so first has to be user ID and then created at, because your query would always be for this user ID order by created at. So when you have an composite index layout as user ID comma created at, it would just have to go through the file block on which user ID for a certain user ID the data is there, and then created at key mapping would be there. So and in that it would start from bottom to up, and then it would access the primary key of the photo and then get the information out of it. So this index is the game changer. So user ID comma created at to render the profile page of the user. Chalo. Yeah, Rana.
Like the second, like the index that you are making on user ID and created at. So let's say like I'm following you, and this is like if I want a feed for all my followers, like that will be useful at like user ID and created at, I will sort by descending and you will get the feed nicely.
No, this is not for feed. This is for user's profile page. This is not for feed. For user's profile page so his or own profile page where you see all the photos posted by him or her. That page.
And like, but why you have created a primary index on created and then
Primary index का created at.
like
Just index.
okay.
Just index on created at. That particular index on created at will be useful to do what? To generate feeds, not out of this table, but to access data efficiently.
Okay.
Because what you might have to do is like give me photos, like you might have a bad job that picks all the photos published in last 1 hour across Instagram, not for a user, across Instagram, and then do something around that.
Okay, but Arpit, to be honest, like I'm a little confused. Like if I'm going for a feed, right, and I will look at those feed only on which all.
This is not for feed. This final index is not for feed.
But this will help in feed only, right? Like why
User's profile page. This will help in user's profile page. Feed is some way. Feed, you will not design it this way. Feed ka design would be very different. Because
Okay.
if you just do give all the users and followers and then you pick out all the photos in descending order, it might still help. But typically that is not the best design of feed because it would make things very slow. Let's say I'm following 1 million people, doing that much of join would put a lot of pressure on your system.
Okay.
So you would not be designing a feed using an architecture like this. A feed design would be totally separate one, which would be event driven. This particular thing, this last index, this is something which would be helpful to render user's profile page, because I would want to see all the photos in descending order of users posting it on the on his or her Instagram account.
Okay. And created that index will help us
To do
when-
batch processing.
Okay.
To do batch processing, let's say I would want all photos, I would want all photos published on Instagram in last 1 minute and just have a count of it.
Okay.
Something like dashboard, or maybe I would want to do post processing of that photo. I would want to trigger anything. So from my source of truth, if I would want to find out all the photos which are created in last K minutes, and if I want to do something about that.
Okay,
That is
got
something
it.
that I can drive through this.
Got it. Got it. Thank you.
Sure. Then comes another table. Yeah. Then comes another table, tags. This tag is very similar to the block tag that we discussed in the first page. So you would have a photo ID and you would have a tag varchar. But a better way to do it is using integers and all, something that we saw. We would be again covering it when we design hashtag and stuff. What is problem here? But this is our typical day one design where we just add tag varchar to it. But obviously you guys know the better way to design it. So we'll start with the poor design and then we'll improve upon it. Then comes reaction. For reaction, what you would have is you would have photo ID, user ID, and is liked, which is true or false. So instead of having a like table, what I did was I created a reactions table so that if tomorrow, let's say we were Facebook, Facebook only had like button. But then what happened? Facebook expanded the reactions from like, then added haha reaction, angry reaction, worried reaction, sad, something like that, right? So instead of having just one reaction, they expanded it to 5 reactions. So keeping the future in mind, instead of having a like table, what I chose to create a reactions table in which I have one column called is liked. Then if I have another column or if I add another reaction to it, let's say is angry or is haha or yeah, or rather is funny, something like that, depending on where user reacted. So one user reacting to a post with multiple reaction. If I want to have that, I can simulate it using multiple Boolean columns. Another way of designing it would be having one integer column and playing with the integer values like 1, 2, 3, 4, 5, 6. So 1 could be like, 2 could be haha, 3 could be angry, 4 could be sad. Like, so there are 2 designs possible for this to just take care of reactions which are part of it. So is like, is funny. So keeping it normalized as multiple columns versus overlapping, because that overlapping into one column, what would happen is it would ensure the uniqueness that one user can do one of the 5 reactions to the post. He or she cannot make 2 reactions to it, right? If that is how you are thinking about it, a better way of handling it would be to have one column. Instead of having this as Boolean, you can have it as a column called reaction, which is an integer. And now this integer would have values 0, 1, 2, 3. Like this is like, this is angry, this is funny, this is sad. Right. So once user reacts with a certain emotion, that emotion key value gets updated here, which means that one value would be there. Right. So depending on the kind of system that we are building, you can choose one over other. Right. But if you see, this is what a good design is. Like, so you'd always need to keep in mind about future changes that might pop up. Right? Key, if I need to make it extensible even for the next phase of it, can I make it with minimal effort? So I didn't have to make a very horrendous decision around it, ekdam wild decision, which covers a lot of cases. It was just a very minuscule decision, but it would have paved a very good way for us to have a very less technical debt in the system. Right? And as far as index goes, you would have a photo ID, comma user ID index. So and obviously unique index, because you don't want uh, 2 reaction entries for one user photo combination. So that is something, a unique index that you not, because this is something that you will need to make query on, right? So given a photo, given this user, give me the reaction that this user has made. Or when making a join in one query, you might want to fetch that. So you need a unique index on that. Then the final table that comes in is relations, basically affinity, where I'm following someone like from and to. So these are 2 foreign keys to users table. So this user follows this another user. So from user ID and to user ID, and then you would have an is deleted, which is Boolean, true or false. So if entry is there or not, instead of doing a hard delete, we are doing a soft delete. Again, the same reason which we discussed in the first week. Batch deleting and all gives you better performance. Right, so this is how a very simple database design looks up, but we covered a few very interesting parts of it. First of it being basically piggybacking multiple reactions. Another way to design the database, you can either do it with multiple columns or one column integer with multiple values. right? This is something which is interesting. Tags ka better design we already covered in the first week. We will again take a look at it in brief time. And then index decision for photos table, and similar index decision that we had to take for reactions table and relations table, where we had to have unique key index for photo ID, user ID combo, and from and to user. Okay, so this is how like a typical database design for a platform, for a social platform like Insta or LinkedIn, something would look like. Right, chalo. Let's start building services around this. Like, so the primary thing of Instagram is what? Like uploading photos. So let's brainstorm around this image service, whose job would be to, once the user uploads a photo, what would we need to do? So let's brainstorm. How would you design this photo uploading service or image service, if you would want to call it? Ideas?
First we need to have our client to check on the format of format of the image.
So on,
That's what I read.
that would still open on the client.
Right.
So now what would happen is, this is our API server.
Once
Yeah,
we
and then
go ahead.
image
Sorry.
image could have different resolutions.
No, what are we talking about is just image upload. That is it.
Okay.
While we receive the image, we can trim down the metadata, that additional metadata that we have, like the location, everything. We don't need that.
But then typically Instagram stores all the location and all, which is part of this thing. Why would you want to remove that? Because that gives you very rich information. Data is the new oil.
Also, I guess removing that would be a problem, because I have on a personal note been working around images, and this metadata is kind of stored in what's called an EXIF tag of an image. So handling
Right.
or removing or some kind of manipulation with EXIF tag generally also varies with the orientation of that image. So if you somehow mess up with that EXIF tag, chances are the images would be upside down or vary in orientation. So I would suggest keeping, if you are manipulating with an EXIF tag or metadata, keep an original as an original image separate, and what transformed as a separate image. One is an original or image or a fallback.
What's the tag you called? XF?
EXIF.
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 But the problem is, if someone just let's say loads that image into a different browser tab, right? And if he or she saves it, then they can look at the image metadata and they can figure out where the user went. So even if the user didn't want it to show that, we can still see that, right? That would be an issue. So for this use case, for social media, this can be an issue.
But generally, images do have this metadata, right?
No.
Yeah.
Social on social media, they trim it down.
Acha, social media
Twitter
pe
does
they
this.
might trim it down.
Yeah, Twitter does this. I'm not sure about Instagram.
Instagram pe to we explicitly tag na ki I was at this location. It doesn't pull it out of
But we do that manually now.
Yeah, exactly. So how would your image upload service would look like? Matlab, you have a user, you have the mobile phone, you check for the format, and now what? How do you upload?
You have generally have a pre-decided URL like upload dot something dot user / user ID / post ID, and then upload it. It was a very simple one.
What would your REST endpoint look like? It will be a post call.
Yeah. Post call to, let's say, / user / user ID / post ID, and
but up till now you have not created any post. So how would you get post ID?
An images / image ID.
I guess just be posted, and it will create a new resource in that particular user's ID's posts.
Okay, so then my URL is just this, but this is not published, because once you create a post, what's happening is you are already publishing it.
Yeah, so this returns me back a URL like user UID post slash some and the as in ID of the resource which got created.
Basically a post ID it would return, nah?
Yeah.
But once the entry is made in the post table, it means that the post is published. But if you see Instagram, once you pick the photo, so then do you directly upload, like for example, if you have a photo that you would want to publish, like so image upload service. So here there are two design patterns. Like always think about like how your end user behavior would be. So there are two design patterns. First of all, which we see in like normal SaaS tools, where you pick a photo, that photo gets uploaded onto the software server, right? And we get a unique URL out of it. And then we do a post, and then we create a post with that URL. Correct? Wouldn't that be a better design? Yes, Artak?
So I think we can do uploads using two methods. So let's say we can have one endpoint for files, for image files which are smaller, and for larger image files we can use something called session upload, in which we can upload using chunks, so that user can resume file upload.
ठीक है, वो थोड़ा एडवांस साइड पे चलेगा, but हाँ, we will definitely come to that resuming upload वाला part. So there are two behaviors here. When we talk about image upload services, there are two kind of behaviors, because if you see the database design that we have with photos, what we need is URL of the photo. So when we're creating an entry there, we would need to pass in the photo URL. How would we get this photo URL? In a post request, if we are going to create this post here, how would we get the URL of the photo?
Arpit, can we have like when we are uploading it, can we have a created like we can timestamp, like a user will be uploading at a particular timestamp only. So that can also serve as a unique key post of user ID.
No, but how?
Basically, the user basically calls the images API, which will return a unique, I mean, which will take the image and return the image URL.
Image URL. So there are two ways to handle it. So typically what should have happened is your image upload service should be something different, right? So there are two design use cases here. First one, where you have a separate image upload service on which user, when selected an image to be created as a post. So first, when the image is selected, it gets uploaded to Instagram server. It returns an image URL, which then is being passed into /post API when the user hits the publish mark. So when you create the post or the publish wala button, that's when the entry in the post table is created with all the details. Because when we create an entry in the photos table, in this table, what do we need? We need this image URL. Right, so this image URL, there are two ways to do it. So here, first step could be to upload image and get image URL out of it. And second step is use this image URL to create post. This is my first approach. Correct. My second approach could be where I am in my post request, I'm also sending the image with it. Well, but how do we send image to the backend server? Image could be converted into base 64 and then passed in as the payload of my REST API. So second approach would be to basically pass photos data in the post request. That is it. In the post of photo, in the post photo request. Right. So first May, what we are doing is we are having a separate image upload service, and then we use the unique URL generated. Now with the second approach, what would happen is, since the post data is there, internally it would upload the image to blob storage and it would get the unique URL for that image.
I submit here. Okay, I have this on.
Chandan, you're saying something?
Yeah, Arpit, actually, even whatever you mentioned, even I was working on this image upload service. Even yeah, we did the same thing. So while uploading an image from the front end, we can create the URL. So using the JavaScript, we have the format like create object URL or something, and that we can just pass to the file uploading service on the backend side, and that will just you will create the S3 bucket, and that will just create that URL. Then you get the sign URL something as a response. Then you use that URL to pass the
Correct.
real data to the backend. So this is the
Correct.
process following.
Correct. So basically, either you can crunch everything into one API call like this, or have it in two folds like this, right? So first, you might want to have a separate post request to just upload an image to the image URL service, whose job would be to just take the image from my local machine, my client, whatever it is, and then upload it to S3 or any blob storage and generate a unique URL for it. Once I have that unique URL, it is written in the response of my post images call. Given that post images call is there, then I create /post call, in which I pass in all of this data with this data like user ID, URL, or not even user ID or ID. I give in URL and text, which needs to be given. Right. So it would then call the URL in text, and then it would send it as part of the post photo or as part of this API /post call for this user ID, and then it would create a post out of it. Right. So this is typically the two approaches that you can take. One of them is better than other in one cases, and the other one is better in some another case. So depending on, so we will tackle both of them. Right. Now comes an interesting part. Let's say you have an image upload service which is just whose job is to just upload the image and generate a unique URL for it. What would be the problem here? Do you see any concern?
What about bulk uploads?
No, that is okay. You might have a bulk upload endpoint, but basically generating unique URL for each image, because otherwise that makes no sense, right? Otherwise, how would you design an image upload service? What would be an issue there? नहीं चमका तो आगे देखेंगे, that's fine.
So since let's say post is rather created, or if you're using the first approach, right? So post ID or whatever the post is created after the image is being uploaded. So what if I change my mind? Let's say I upload an image and I don't want like hit the back button. I wanted to upload a second image. That might create something of an orphan file.
Orphan file is cheap because because blob storage is cheap. That's okay. But how many such use cases would be there? Orphan files for blob storages is nothing. They typically take up no space there. We will anyway come to it. I thought we can do that part of it. Okay. We will come to the interesting problem there. So let's say we're uploading 2 million photos a day. One typical approach that was used long back when internet was very young was people typically uploaded the photo to a server. In the HTTP request, they used to pass it as a file upload or something like that. Then this file was sent over HTTP to your API server. This API server used to store it onto a local disk, because at that time cloud blob storage were not there. But if let's say we have S3, you would use this file being uploaded to the server, and then with this server as part of the business logic will upload it to the S3. Right, and then you would make an entry in the database about it. So user uploads the photo using API. In the post request, image is sent as base64 encoded, because otherwise, how would you send data to your API server? How would you send image data to it? So you would read image data, convert it into base64, and then send it as an HTTP request. Your server decodes or creates image using base64 data, uploads it to S3, and then you get all the information, and then basically makes an update in the database. This image, which is then uploaded to S3 on a certain path, this path is then converted into your public URL, which then gets stored in your photos table. right? This is how a typical would look like. And so this is how the approach 2 would look like, right? So the approach 2 was like one post call where you have users photos data being sent in the post call and you build this part. So when you're uploading photos, you do this. This is what your second approach would look like. The problem with this is when you make just one call, you are making 2 hops. So one, let your image is what, 5 MB big, for example, let's say it's 5 MB big. So from user's client device, 5 MB data transferred to your server. Now this server would have to transfer this data to S3. So again, 5 MB data transfer. And obviously both of these calls are expensive because network pay, when you're transferring 5 MB worth of data, it's more expensive. So instead of doing it twofold, we can directly upload it to S3 to save a disk write. So to save a disk write or your server's memory. Because if you see, when you're getting this much of data in your HTTP request, all of this data is stored where? In memory. All transient TCP request or REST request that you get in, it's all memory bound and not disk bound. Not HTTP requests are not written onto the disk. It's part of your memory. So it's memory bound. So the 5 MB of image data is held in your memory in your request.body or something like that. Right. So this is what would make your server a little crunched for memory, right? When you are uploading photo to server and then server to S3. Plus, not to mention, like, plus another thing to mention is like network IO, like 2 times you're transferring 5 MB data. So 2 times the data transfer cost you would be paying to your cloud provider. So a better way to do it is by keeping your servers lean. How would you do that? Typically, every single blob store comes with a signed URL concept, where what you do is you make a request to the server. Your server generates, or your server talks to your blob storage, say S3, and it would pick your S3 would generate a signed URL. So you would say, I would want to open up a path on S3, and give me a signed URL for that. Whoever has the signed URL can make a post call on that signed URL and upload a file directly to that URL. This way, your 5 MB worth of images data, instead of going to the server, so server gets this key. Your client says that I want to save this image. Your server says, okay, here is the URL on which you can go ahead and save. Your client then makes a post call to that URL, to that signed URL, which then directly stores the photo onto S3. So now your 5 MB data transfer happened just once from your user's device to S3. So now your server become leaner. And then once the upload is done, the image is uploaded, and then when you click the publish button or post button, that's when your entry gets created in the database optionally. Okay, now my photo is there. Now I'll create another entry in my database when my post is published. Otherwise, I might have few orphaned images. That is okay, right? So this is a better way to do it because this keeps your API servers lean. Your data transfer cost is just once because your users data directly transferred to S3 and not like server and then server to S3. So this is a much better approach than the first one where you would have to have a bulkier server to handle those many concurrent requests. Right. So user now makes call to API server, gets the signed URL, and now how the signed URLs are protected. So these signed URLs come with an expiry. Typically, when you ask S3 to generate a signed URL, you also give it the expiry. Let's say 5 minutes. So in the 5 minutes, user would have to upload the image. Otherwise, that URL would be expired. Right. So you'd configure the expiry depending on the use case, and then the client would directly upload the photo to S3. You don't really have to worry about that. So if the upload fails, it fails. If it passes, it passes. Once the photo is uploaded, and you'd see that photo being uploaded there, and you save the button, you hit the publish, and then that would be used as a photo URL being stored in your posts or your photos table that you want. Right? Clear? A better way to upload images and all? Yes, no?
Can
Yeah.
servers generate these signed URLs ahead of time, like keep a batch of them?
You can do that, but it's not that expensive of a call. Typically, you do it on demand. If you batch and keep, there's a very high chance that you would have to have a higher expiration time for that, which means someone getting those signed URLs access might abuse it because expiration time would be higher, right? So you would want to keep time very reasonable, so that like no one would be able to upload a very magnanimous file onto the S3 or something like that. And so
Okay.
it is typically done on demand versus keeping it a batch. And it's not an expensive call. It's just like one API call on S3 and you get the response like 200 ms worst case. And that is P99 of it.
And Arpit, like checking on the constraint, it's better to do that on the front end side, right? Like
Yes.
2 MB, less than 2 MB or something like that.
Yes.
Okay.
Typically, all of the constraint checks about file format, file size, and something, these are all part of business logic on the front end side. And you can also optionally apply policies on your S3 bucket or your signed URL. So those policy might say that this bucket can only contain, or this signed URL can only accept file with a certain MIME type. You can configure that, which means that even though you say that I'd only allow JPG images or PNG images, but if someone uploads a PDF file, your S3 would not accept that. You can configure those rules.
Yeah, the same thing. Like we are checking the file format on the front end, but the
You
size
can also
we are
same check. So size wala constraint also you can check it on the signed URL. No, sorry. On signed URL you can't check that. But you can have a maximum file size limit there. But on client side, on front end side, you can definitely check that.
Yeah, or maybe when the image doesn't get uploaded to S3 in the catch block, while capturing the error, we can send this message,
Yes.
right?
Yes.
By
Yes.
catch.
Definitely. Definitely. Yeah, Vishal?
Yeah, so here, when I upload the image, it will
Mm.
go to S3 and using the
Yes.
signed URL, right?
Yes.
So then in the response, I'll be getting the signed URL. The URL.
So the signed URL, once I've uploaded it to the signed URL, that signed URL, so what do you get? You get, so when you're making call to the API server gives you two things in the response. First is the signed URL on which you have to upload the image, and second one would be the path of the image.
Okay.
Right, so you'll get two things here. So the path of the image would be something that your front end would know that you would have to use once the image is uploaded. If it uses beforehand, it would not render anything.
Okay. And so once it responds with the path and the signed URL, so I'll be again sending a request to signed URL, right, to upload,
the photo. Once once the
upload.
photo is uploaded, you'll use you'll use the other thing which you got in the response, which is the actual path, right, and use it as your photo URL.
Okay, and then I'll again send a request to server that I have uploaded.
Yeah, no. So basically, once your image upload is done, that is okay. Now what comes in is your post is basically publishing your post, right? So you can piggyback the logic in post publishing, because once you're publishing the post, you have to give photo URL and you have to give text, the caption and location and other details there, right? So that would be part of that. You don't have to explicitly mention ki I have uploaded the image.
Yeah, so there'll be basically two calls.
Basically two
First
calls to do the photo to do the post on Instagram.
Yeah.
Okay. Sure. One very interesting thing that I want to discuss, like a little off topic, but if I make this as a very generic service, so whenever an image is uploaded, let's say I generate a random URL for an image. So let's say I pick UUID or any random ID generator that we saw. If I take a random URL for every image and then I use it as part of, because I have to write a very generic service which does my image upload. So if that URL is very random, let's say ABCDPQR is something very random, like random 64 characters long string. This, although it seems like it works very well, I'll give you a very nice example where it might create a problem. Say you have your profile photo on Facebook or Instagram, okay, and you update that photo. If your data is not normalized, let's say you're using NoSQL database and your data is not normalized, which is it is denormalized. Let's say your user basic information is added on every post ka data or every photos data mein, right? So then it would also contain what? It would also contain the profile icon of yours, correct? Given that profile icon of yours exists on every post and you update your profile photo, which means earlier there used to be another path of the image. Now that path got changed. Now, would you go back and change all the documents in which that thing was referenced? That is the problem, right? Because that would make things very expensive, right? So I'll again reiterate the problem to help you guys understand it. So let's say I chose a design where I have everything denormalized. I have a table called post. Each post has like URL, then user ID, or I have user ID, and then I have called user detail. And I have this thing as NoSQL database, right? So no foreign key references, nothing. And it is denormalized. And in user detail, I have user ID and profile photo. Right. And now this profile photo is something that is also going through the same path, image upload service. Now, if this profile photo has path like /abc/ijk/123.jpg. So this is, let's say, some random URL which was generated from my image upload service. And this is being done here. And let's say I have 1000 posts like this in my system. And now if my user updates the profile picture. So now user made 1000 posts. Second, each post looks like this, has this. And now third step, user updated profile picture. Now what would happen? Now when we are rendering the post of a user, we are using user details or profile photo to render the small circular icon having the user's photo there. Right now, the problem that would come in here is that this document has the older photo ID which still exists. Right. So when the profile photo is updated, you'd have to you'd have to go through all the posts made by the user and update the profile photo in user details of it. Correct?
Yeah.
Right. What's a better way to do it?
And maybe
Yeah.
save it as a user/profile photo and replace it with it.
Correct. This is a great design thing. So instead of generating, go on.
Maybe a soft link sort of a thing. It points to the latest photo.
Which points to the latest photo. So two ways to handle this. So typically this is how Gravitas work. If you know what Gravatar is, this is typically how Gravitas work, and a lot of companies rely on Gravitas to render a default photo. So Gravitas, so if you are having discussion around designing Gravitas, this is how the major problem of it could be. So there are two approaches to this. A is have a static URL for some exceptional cases. Let's say for profile photo, you would have /profile/user_id.jpg. This is always going to be the path of the user. So even the URL that would be generated by the signed URL, it would also take in for what use case are you doing. So if it is like profile photo, you would generate the same URL, the same signed URL, not the same signed URL, but the same signed URL for the same source path on S3. You generate for the same path on S3 the signed URL, and every time when the photo is uploaded, it will always be replaced. It will always replace the original photo that you have uploaded on S3. This way, when the photo changes, the path would not change. So the path here was /abc/ijk123jpg. For a user, it would remain constant. It would always be /profile/uid.jpg. So /profile/userid.jpg. It will always be this, which means when your source of truth or once your photo changes or re-uploads at the same location, the changes get automatically transpired to all the posts that user has made. Case number one. Another approach to do this is using something called as soft links. I would definitely urge you to check out how would you implement soft links, because there you would come across very different concepts which you would find really amusing to discover. So thoda sa dekh lo, maza aayega usme, because there would be few really amazing things that you will find out, and I would really not want to rob you from that. So soft links, a photo. So you would have one URL and then it basically points it would always point to the latest photo of that URL. So just changing one link at one place would have this thing changed at all other places. So you would still have /profile/userid.jpg as one constant URL, but then internally it would point to one or the other random URL which was generated by your image service. So soft link to latest image of photo. Okay, clear? Two approaches to tackle this problem. Yeah, Pradman.
So in the first solution that you gave out, the URL would stay
It would always remain the same.
So what so speaking on personal experience, since we use DigitalOcean instead of AWS, what happens in DigitalOcean if we keep the same URL, right? On DigitalOcean spaces, it also CDNs to that. There might be caching issues.
So for that, for some, then two approach: either explicitly invoke cache invalidation, or let cache automatically invalidate.
So when we designed this, what would happen is the user would continue to see the old profile picture because it was cached. So every time we would have to do this, we would have to manually purge out the cache also from the CDN.
Yes. वो तो करना पड़ेगा. Yeah, but obviously you can either manually do it or let the cache expire. And if a cache expire is way too long, then you would have to explicitly do it anyway.
Yeah, ours is way too long just because it's a media.
Obviously, you are not expected to change the photo quite often. Right?
Since being a content heavy workload, so you need to be cached for a long time.
Great insight. So always keep in mind, Matlab, there are so many ways. Now, this is not just specific to social network. You can expand it to a lot of places, right? So we'll just quickly cover this photo upload part, and then we'll go on a quick break and then cover the rest 2 or 3 design more. So now what do we do is, once we have uploaded the photo, what we want is we want our photos to be served to user at a very fast pace. So obviously what we use is CDNs, Akamai, Cloudflare, CloudFront, and whatnot. So how CDN would help? It would lower the response time by keeping a local copy of the image onto edge servers which are there, so that users, when they are trying to access the photo, the request would always go to the nearest edge server, and so they would get a very minimal bandwidth. So they basically CDN optimizes network, basically time for the network call to happen to fetch the static resources. So this is a classical case of CDN. So typically every single image service has a CDN configured. So no one, but obviously it always falls back onto your public blob storage that is there. It will always have a fallback on this. So due to any reason, if your CDN isn't working, or if your CDN, sorry, not working, if your CDNs or if your CDN does not have the data, it would go back to your S3 or your blob storage on DigitalOcean, GCP, anywhere from blob storage. It would take that data and cache it on this CDN and then stream it back to the user. So this is how this is typically what would always need to be in front of your image bucket that is there and part of your blob storage. Okay. Now optimizing images is something that we'll start taking a look at. So image upload at scale, CDN, direct uploading to S3, signed URL, updating images, like 2 cases of image uploads, one where URL has to be static, 2 approaches to solve it, soft links, and uploading the photo at the same path. If it is cached for a very long time, invalidating the cache. And the other part was what I forgot. I forgot something. I actually forgot. I was under the flow and I went into DFS and I forgot what I wanted to cover. Okay. But anyways, we covered quite a bunch of it with image upload part. So okay, another upload. So instead of directly uploading to S3, you can always go through server and then to S3. But your server's memory has to be a little bulky. And while doing both of this thing, you should always have a client-side checks to ensure that file size limit is there, like maximum 2 MB, 5 MB, whatever you'd want to keep it a limit. File format, like only images should be uploaded, like not PDF, Word, or any other random files. So all of those checks has to be applied on the front-end side of things. Yeah. So this is what image uploaded scale looks like. And to distribute the image, you'll use CDN to do that. CDN might need to flush, and advantages of CDN. So we did cover quite a bit of, right? We'll take a quick break of 6 minutes. Let's catch up at 5:20, and then we'll go into optimize images, hashtag extraction, and yeah, that's it. Okay, chalo. See you at 5:20. Thanks, sir. now coming to the next part. So now that we have uploaded the image, now comes that part when someone did point out about about various resolutions and all. So now what would come is, how do we optimize the images? Although we did see an optimization around the times that user might spend on network IO to fetch the image by using CDNs. But there is another thing that needs to be optimized, is we need to do optimization on top of resolutions, right? So like depending on the network bandwidth of the user, Instagram would want to show a low resolution image to a user having slower internet versus a really 4K HD, like जो भी best images possible to a user having very high speed internet, right? So basically giving the user the best experience. Question number one, what would happen if we don't do this?
And users with low bandwidth will suffer, because of which our P99s will go down.
Correct. How would they suffer? What would be the impact? There would be two major impacts.
Data being used up, more data being used up.
And
And
second,
Loading would take time.
loading time. So poor user experience in terms of their higher data consumption. And second, they would see that loading wala icon, right? So these is where companies that operate at scale have to optimize things on. Yeah, Piyush?
And when would this happen? So let's say we chose the path where we went with the signed URL of S3.
In both cases.
So this would happen as a bad job?
What would happen as a bad job?
Like
This image
when would
optimization.
this? Yeah, because
You would-
usually is uploading it to S3, right? Where do we, like, we are nowhere in between.
Exactly, that
this.
is what we would have to build. Na? Pehle upload kar diya. We have not done any optimization on
Yeah.
that. Na? Now
So
what do
it
we
would
do?
be a bad job, right? Sort of like a bad job.
Kind of, but we will design this optimizing service right now, and we will see how basically how do we design that.
Okay.
Sure. So a great point being brought here by Piyush is, like, we have uploaded image to S3 and we have stored it as part of our post data, which means when rendering the feed of the user, this post URL is something that would be used like directly, right? So this image optimizer needs to kick in somewhere. Okay, how would you design this? Chalo, let's
On
brainstorm.
post, we'll put an event, and on post, we'll just put an event, and we'll have a consumer which actually does the optimization.
So you would use a queue on publish, and you would have a consumer. Now, what would this consumer do?
It converts all the images to its, I mean, maybe all the formats, and it'll save in the database. It'll update in the image URLs section.
So up till now in our database design, we had just one URL. Now, are you suggesting we would have multiple URLs?
Yeah.
Okay. So one change that Varun recommended is having multiple URLs.
What we can do is we can save the ID of the image, and based on the, like, we can have sort of like predefined, let's say we have image uploaded with 123 ID, and then we can have like 123 x64, 123 x128, something like that. So based on the resolution, we'll choose the ID, but we will select the resolution based on the bandwidth.
Okay. So path having details. Example, UID -64.jpg, user ID -128.jpg, something like that. So
yeah,
depending
post
on
ID,
what the
sorry, yeah.
bandwidth is, you would just change the fag end part of it, right? But then it might be possible that the post processing might not, this image optimization might have taken some time.
Yes.
But your feed is rendered, it is seeing that internet connection is low, so it used -64, but -64 doesn't exist. Now what would you do?
So in that case, we can fall back to the default image with this
Image
with
fallback, how
the-
would you implement? How would you implement image fallbacks?
the very first thing that comes to my mind is to check if we have something with, let's say, x64, and if we don't have that, we just use the default.
How will
like
you
there would be
identify?
image.
How will you identify that? Matlab, see, image fallback on client side. How will you implement image fallback on client side? Because you can't have, see, image can have alt tags, which could be a text if the image is not there, but you can't have image as an alt to another image.
Like HTML, this is being very naive of a solution, but HTML does have like an image and a fallback tag. So if let's say we save it in a one web similar to what WebP format is, it's kind of very get to go by and very lightweight. So what we do is we first convert once we convert an image to a WebP, and we keep the original one as it is. So since some browsers and some devices doesn't support WebP, in that case automatically the fallbacks kick in.
But
this
how will
is-
you implement? But how will you have that in HTML tags?
This the image tag,
Image tag, mein, huh.
you can have an image and a fallback thing.
So is that so? I'm just trying to get the right answer from you. Like more details around it. Like as a I know how to do it, but it's
Okay.
just that I just like to probe you to to basically utter that.
The client will actually by default will have the default path. For example, the client will know uid.jpg, and according to the speed, let's say it's a mobile client or something, so that will know which speed to call to. So the first it will know uid.jpg, then it will call uid underscore something.jpg. So if that fails, it already has the default URL.
But
Like-
then you have already consumed the bandwidth of the user. Or rather, now you are making it even worse because you first fetch uid.jpg and then you are bringing in the lower resolution. So higher resolution you have already consumed. That's the
No,
problem.
no. I'm saying uid.jpg, the client knows. It won't query on that URL. It knows that that is the path. But uid underscore something dot jpg, that's the first logic. That according to the speed, do underscore something dot jpg. And if that does not happen, then go to uid.jpg.
Okay.
Can we have a different API server which kind of gives back a result based on the network conditions? Like the first API is hit, which is used for fetching. That internally calls another API with based on the mobile device or the headers which it receives.
We will come to that. That is basically dynamic. Basically, that is part of the dynamic optimization. So now that we are on that topic, so here, as part of brainstorming thing, what we discussed is how to do image optimization. So once the post is published, which means that image got directly uploaded to S3 using signed URL, and then user hits on then basically user did a post publish. Now the post published way, we send a message onto a queue, let's say an SQS queue or RabbitMQ or whatever it is. So once the message is published, it says that this post is published, and then the consumer of this message would be your image optimizer's consumer, whose job would be to pick the image URL out of the basically out of the body. Once it gets the image URL, it would read the image URL and then convert it into multiple formats. Okay. So 64 by 64, 128 by 128, 256 by 256, maybe PNG to JPG and whatnot. Right. And once it does once it consumes, it would either update in the database and obviously upload it to S3. So the consumer has to first upload it to S3. Once the image is uploaded to the S3 with this like /profile/user ID -64.jpg, then it would make an entry in the database. One approach that was recommended was instead of having one photo URL, have multiple photo URLs part of it. Right. Another approach was let my client be smart and append -64 -128 depending on the internet strength of the device. Right. One problem with this approach is like you would need to implement image fallbacks on the front end, and there might be a lag. For example, I made a post, a very high quality post. So basically high quality post as in my image is of very high quality. And once I made a post, it sends notification to a lot of my users, to a lot of followers of that user. And let's say for the celebrity, a lot of followers are from tier 3, having very poor internet connection. So now those user, they have received the notification or they see it in their feed. Now what would happen is their internet bandwidth will get consumed, right? Although this sounds very nice, but when you do an asynchronous part of it, it takes, so there would be delay in doing the post processing of an image upload. So another solution to this is doing dynamic optimization. So similar to how we altered the path of the image, there is typically a third way. Jisme, what we do is we give image URL is /abcpqr something 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 /uid.jpg, and then we pass in query parameter like width is 64. So you can specify width, height, and all of these things. So instead of this URL goes through the CDN, comes to not go, but it does not go to S3. It comes to a backend server whose job is to fetch the image data from S3 and send it back. And to fetch the data from S3, do some post processing and stream it back. Now, what would happen with this is, let's say a very high resolution post was made and uska 64 by 64 ka resolution it is requested. So this request would come from the client depending on the bandwidth. It chose like 64 by 64 is something that I have to render. So it came as a request. So it would add like $w equal to 64. So width equal to 64. This request goes to the CDN. CDN says, Array, I don't have this URL cached with me. So basically I don't have this data. So the backend of this CDN will not be S3, but your API URL. Now this API URL could be a different image optimization service whose job is to dynamically optimize images depending, or basically dynamically resize images on request. So rather on demand image resizing service kind of stuff. So what it would do is, once it got the request from the URL, it would fetch key, okay, I need this image is part of this S3 bucket at this position. This server, when it got the request, it read the image from S3. It did it, and then it did the resizing depending on the query parameter it get. It sent back as the response. Now this response would be sent back to what? CDN. This CDN would now cache the response. Now this caching time would be very high. And now this cached response would be sent back to my client. So my client on demand received an optimized image. It took a little bit of time, but it received an on-demand optimized image. So here network bandwidth is saved in favor of an optimize at the cost of a little lag. So higher data. So instead of transferring 5 MB of data, let's say 100 KB data made is done. So it saved the user's network bandwidth against a little bit of time, right? So this is a conscious decision which has to be made from a product's requirement. And I'm just making you guys aware about the third approach, which is like really popular. So there are actually AWS very recently published a blog about dynamic resizing images on AWS, and then they just give a one-click cloud formation template to deploy a solution like this, right? So so if you are on AWS and you want to give it a try, you can just in one click have those entire infra setup. So it uses serverless functions. So you might not even need a dedicated infra, or you might not need a dedicated server for it to run. You can scale it with AWS Lambda. So every time the request comes in, it spins up a container. That container picks, basically when the code runs, it would download the image from S3, resize it, and send it back. While sending it back, it would go through the CloudFront or your CDN where it would be cached. So similar request coming from other clients would go through this same edge server, but now it would have the data. So it would not have to call the dynamic resizing every single time. Only when it is not available on the cache, that's when it would have to pick. So this comes in very handy in the case where your access pattern is very spiky, right? It is not consistent, because that's where this comes in very handy. So if your access pattern as in, let's say your image or your any photo, like for in case of Instagram, like a content lives for a week or so, right? After that, no one even watches that again. So if you know that 7 days is that golden time, what you would do is you would cache your image for each resolution like this on a dynamic resizing for 7 days on your cache or on your CDN. Right. So any request that would come in would be directly served from CDN, and it would not even have to go to backend server. So you don't need the expensive infrastructure to, every time do this part, key API on publish, consumer, DB, S3, upload and all. And let it be dynamic. So this way, what would happen is you would only be converting stuff on what it is actually needed and not like doing it for every resolution and everything possible. Right. So this is third way of doing it. So and the true solution or the actual solution being used in the industry is combination of is basically the combination of 2 and 3. So you can have a path-based thing where multiple URLs are stored, or basically the combination key where you do SQS wala processing, where you are creating for all resolutions and everything there, or you can do dynamic. So for newer data, you might go for dynamic unless the entry is there and then do this. So clients are made smarter about that. And then depending on what kind of data it has in the response, it would either make a call to an on-demand stuff or an existing one. Clear?
So here the client defines the height and the width, right?
Yes.
So that can be prone to abuse because they can just, because that defines
Yes.
the cache period.
Yes. So typically what you do is you just try to save your request. It's not just normal request that you get, but you add some headers to it just to recognize that the request is actually genuinely generated from an authenticated device. But obviously this is abusable. You can see it in action in a lot of cases, like Facebook images, when they load, they have this query parameter with it. Just change it to a bigger resolution and you would on demand get a bigger size image. So Facebook at some places used to do that. I tried it about a year back, and there was very site which I saw very recently, which did this. So it sent 64 by 64. So it used to render a square profile photo of a user, mostly LinkedIn. So then I changed it to 256 and I actually got a 256 by 256 image out of it.
Like in my company, we had a use case where we used this third condition. But in the backend, we had like restrictions. We would have 3, 4, like 4, 5 sizes. If that is not provided, the request is rejected.
Yeah, obviously you would not have it like, you would not actually keep it wide open. You would just have few sets of widths and heights that you support, and only those are allowed. All others would be, not entertained. Obviously you would have that. Yeah, Chandra?
Arpit, is it a better option to like have most frequent images like logos of the page or something on the server machine instead of showing that in S3 or something for the better performance?
No, S3 would always be faster. S3 in combination with CDN would always be faster. Why would you want to keep it on server?
Or let's assume the very logo of Instagram itself, like if any issue comes up, like as a backup option, we'll have that on the server machine. So instead of getting that from S3 directly, we can send it from the server.
Which server? So your API server or your front end server, part of your front end code?
No, API server.
Why would you want to do that? That's an overkill. That's a very big overkill, because your API server now has to serve, like, let's say even if it is 100 KB of an image, it has to serve that 100 KB in memory and send.
Oh, no. Yeah. Oh, what about front end machine? If we store that on the front end code, like
typically in the static or the assets folder, we do that. But if you see, your front end code is also served via CDN.
Yeah.
Right. So you can do that. Yeah. So because anyway, your front end code, your static JavaScript file would be sitting in front of a CDN.
Okay. Yeah.
Right. So image is anyway going to be cached on CDN.
Okay.
So you can do that. So so here what we're talking about is like in general, like photos and all that we have on Instagram.
Okay. Yeah.
Right. So I'll just add a note before I take note. Prevent abuse. Okay. Yeah, Vishal.
Yeah, so what are the typically methods used for detecting the network speed?
If you see the navigator of your browser, so window.navigator, it has a bunch of information. So through that, you would identify the internet strength, you would identify the network, and then there are also ping protocols that you can use. So once a while, your front-end server pings your backend API and it measures the response time. So this basically kind of a heartbeat on which you will judge how strong is your network. So just
Okay.
check out window.navigator and ping response times. These two are the approaches through which you would decide कि क्या करना है. ठीक है? Right. And this is exactly what we'll be discussing. So yeah, so with the brainstorming session, we actually get a lot of nice ideas, but then to just summarize all the things in one place. So once the image is published and uploaded, we may want to process it and optimize it for various devices and platforms. Like, for example, a great example given was WebP, but not a lot of browsers support it, or not a lot of devices might support it. Like, not a lot of low-end devices would support that one, right? So you would need to have your image to be there in WebP format, JPG, PNG, and whatnot, right? But doing it every time might be an overkill. That's where on-demand comes into the picture. So as a combination, you would have to pick both. So once the user publishes the post, you would make a HTTP API on API server. That API server then would call your optimizer service, do the update on your database, create images on S3. And how would you do it? You would use packages like PIL. So if you're using Python, you will use PIL, which internally uses ImageMagick or something. So these are system utilities. So no magic there. So there are some pure language-driven libraries in JavaScript if you want to use, but C wala processing is much faster. So you'll get language bindings for ImageMagick and whatnot. So you'll use that to optimize images. So like FFmpeg for video processing, ImageMagick for processing images and all. So when image is uploaded and post is published, your post looks like this, ID and photo and something like that. And your image optimizer pay, once you do that, you'll add. So this was the first approach where we add, instead of having one photo, once it is post processed, you would add photos. So earlier we used to have this one attribute called photo. Instead of that, now we have added one more attribute called photos because it is schemaless. With photos, you might have a low, medium, and high, depending on the resolution that we have, right? So we will create different images on S3, and we would either update the database ka that row with this kind of information. So depending on the resolution, depending on the network strength and the resolution of the device, your client would pick photos.low if present, otherwise call.photo, something like that, right? Unless there is this on-demand service. So image optimizer will get image as an input, and it will create multiple images for multiple devices and quality and store it on S3, and then update the database with the new photos URL. Right. Now, how will your image optimizer learn about the new post published? Is simple. Your API server will tell. So you would need to have a broker. Like, you would not want to have your API server directly communicating with optimizer service and expecting it to do that action in real time, because processing images would take time. So this is something that would have to be asynchronous. We would have to delegate. So once photo is published, it would trigger a job. It would push it into a broker, a queue, SQS, something, and your optimizer's consumer would consume it, would update the database and create images, right? And while doing all of this, our CDN is still there. It's still sitting in front of S3 and doing its part. So it is still sitting on top of S3. The new photos that are uploaded to S3, they're also served via CDN. So if someone calls it, it would get cached on the CDN side, right? So it is still there. So depending on the network speed, so the few parameters that you would have to consider if you're on the front end side, and the few parameters that you would definitely have to consider is network speed. Battery plays a very important role. So typically the light apps of like Uber, LinkedIn and all, these all also consider the battery which is available on the device. Okay, that plays an important role. Higher network call, higher CPU, lower battery, so higher battery consumption, so low time milega battery ko. So battery, device resolution, depending on this, you would call that part, right? So And the 10th thing is all of this thing is passed using query parameters using dynamic loading. If you are doing that dynamic loading wala part, so you can pick that part. So on-demand service. So something on-demand service is not something which I plan to, which I wrote about. We just covered it during the brainstorming part, but obviously that is a very famous strategy as well. So doing on-demand image resizing and optimizing. So that is an additional thing that we cover. Sure. This covers the part of image optimization at scale. The third part that I'd want to discuss today is hashtag extraction. So like without hashtags, platform doesn't go viral or the post doesn't go viral. Like people use random hashtags on post. So that is an integral part of it. So let's brainstorm around tag extraction. How would you design a tag extraction service? Again, a very similar architecture. I'll just do the mundane part and then we'll jump onto the interesting part where I'll pitch in your ideas. So I'll get this thing, user making call to our API server. Our API server pe on publish, like SQS pe, it got the message, something like a consumer, a very similar architecture to image resolution, right? As an image optimizer service. Now this consumer would do what? Tag extraction. Now what would be, and then what would it do? You would have a database here. Sure. How would you extract tags out of things? And what would your consumer do?
I mean, anyway, user should keep a hashtag, so it will just basically extract that info. So now
using
we have
regular
tag.
expressions.
Yeah. So
And
once we have that info, I mean, we may have to map the post to tag ID basically. So we need to have that info, what post contain what tag, and so we'll have a relation between posts and tags, an entity which maintains it. And we, based on that, we can, I mean, once we populate it, we can actually filter.
Correct. So we need somewhere. So in the initial database design, we had this tags table, this the photo ID and tag ID was there. But in the first week, we saw a better way to manage tags. So having a separate table for tag ID and tag actual string tag, and then using the actual string tag, we would get tag ID and then start putting entries in the tags database or in the tags table. Right? Any concerns with this? Any concerns that you see in general, every one of you see with this kind of stuff? So because this is our main database, we have a tags table.
Too many joins, so we can use maybe, I mean, if we separate the tags name with ID, too many joins, maybe we can use materialized views for optimization.
Any other concern?
Also, the regular expression that you're using, like, is a costly operation on database.
No, this regular expression will not run on database, na? Because once you get this thing, your consumer would get the exact postcard data, na? So postcard text it would get. It would be a CPU bound process and not go into the database. It would just extract from the text that it has.
Okay.
See, this is where back of the envelope calculations come in, right? What's the how many tags per post is an average for Instagram?
2 or 3.
2 or 3 is too less. It's 8.
Yeah.
It's
5 to
number
6.
published by it's number published by Instagram. So 8 is the average. People give 100 tags to a post, like, and most of the captions, they just contain hashtags, no text, pure hashtags, right? Because with hashtag they get basically virality, right? So they let's say 8 hashtags, which is the number published by Insta. Okay, 8 hashtags per post and 2 million posts a day per day. So if we multiply this, we would get 16 million tag entries. Right, not unique one, but the post to tag entries that is there, which means 16 million writes would happen onto your database or onto that one table, which is where the chances of explosions are big. And this is 16 million entries per day. Like, so just see the way the growth is going to happen. Right. So now this is where the concern would come in. So for something which is high explosion growth, this is where your database writes would start to become a bottleneck. And since these are writes, this has to go to the master. You can't have a separate thing gone. So this is where your design needs to be altered. So at a very basic scale, things would still work out. But if you see, if your average number of tags per post is high, it gets multiplied, right, with the number of posts being made per day. And on peak hours, when there are like thousands of posts being made on every second, your database would die, would literally die if it sees an average of 8 posts on that tag. Right. So this is where the concern is. So this is where the challenge of designing comes in. So what do we do? We'll see how do we tackle this problem. So when a photo is published, it contains a lot of meta information with a mandatory caption text. So you'd have a photo, you'd have some caption, and then at the end there is hashtag, like hashtag sunset, hashtag food, and some obviously some meta information along with the photo which user explicitly granted was geolocation, people tag, time of the photo user was the time the photo was taken, and something like that. So we would have something very similar to this thing: photo publish, broker, tag extraction, update. This architecture is very similar to image optimizer. But if you see, there is one issue, but overall, like is there something that we can do about this? So this architecture is very similar to like our image optimizer thing. Any issue you see here, or any optimization that we can do with respect to high level architecture? This is the issue. So you need one SQS queue for image optimizer. You need another SQS queue for tag extraction. Right. So every time your post publish is happening, you are having to call, like if your post is published, you would have to publish one message in for image optimizer queue, one message in tag extraction queue. So let's say for a post publish event, there is like 50 different things to do. Would your post publish call should like push messages in 50 queues? That would make your API call too slow. Right. So this is where, since the same event we are sending to multiple queues, this is a better way to do it is, so this is a classical case where we have to use event driven architecture. So from the same event, we are sending messages to two SQS queues. If there are any other cases, any other use cases, you would be sending this. So your response time will shoot up, and obviously like some or the other would fail, and like this can be done in a better way. So this is where what kicks in is event bus. And this is where I would have to introduce something like an event bus to you, which is like Kafka or Kinesis. So what event bus would do is, this would lay the foundation of event driven architecture. So you'd have a bunch of publishers who are publishing the events to it. For example, your main API server, like on post publish, on post like, on user follow, these are events. And then there would be multiple subscribers to it. One subscriber could be your image optimizer service. Another subscriber could be your tag extraction service. So all of the subscribers would be subscribing on a certain event. So this event is post publish. So there would be other subscribers and other consumers would be consuming some other event. So this is that one stream of data which any consumers or any subscribers would be consuming from the queue at their own pace. Right. So instead of publishing the message n times for n use case in n different message broker, event bus ensures that you would just have to publish the message once. The same message would be read by multiple consumers, unless like your broker, where a message is read by just one consumer and then being deleted, or homogeneous consumer, something we discussed in the first week. This is a classical case where you need a backbone for your architecture, which is what event bus would give you. So photo published, user created, photo deleted, all of this becomes the event which gets streamed onto event bus, and services will have to consume the events and perform actions accordingly, right? So this is where tools like Kafka, Kinesis come in, and these are typically called as data streams. So event streams, message stream, data, and these are all homogeneous. These are all synonymous terms to it. The idea is simple. You have publishers publishing the message. These messages get stored in Kafka for long duration. Let's say 2 weeks is typically how long people store messages in Kafka. Now each service, let's say first is image extractions, image optimization service, and the tag extraction service. So these services would consume messages at their own pace. Let's say service 1 does a very little thing, like a very lightweight service. So it is consuming messages much faster than service 2. So service 1 has consumed message 1 and 2, while service 2 has just only consumed message 1. But my messages in my queue are still 1, 2, and 3. So if there is another service that comes in, let's say service 3, it would still see the messages 1, 2, and 3. So it can start consuming the messages 1, 2, and 3. Now, when would the messages get deleted? Every message would stay in the queue for 14 days and then get deleted. So this is configurable, right? Which means your consumer can pick, okay, I want to start consuming messages from first, well, first as in from the time or the queue for all the messages in the queue starting from the oldest messages, or I just want to consume the newer messages. So these are horizons that needs to be configured there. What's your consumption strategy? Right. So this is a great use case where you would introduce something like Kafka or Kinesis into your place, where there are heterogeneous consumers. If you see, these are like for the same event or for the same message, there are heterogeneous consumers. One is image optimization, another is tag extraction. There might come in other thing or analytics or something. So these are heterogeneous use cases that come in, which is where your event bus becomes the backbone of your system. Okay, so the same message is getting delivered to multiple consumers or multiple services that are there. Clear? And this is a classical case of an event-driven architecture or an event bus. Any questions here?
But even here, at the end of the pipe, the writes are multiplied across the consumers.
Yeah. So up till now, we have not solved the problem. I just wanted to give you a very nice holistic view of event bus and event-driven architecture. So writes ka problem we will solve. Okay. So event bus is clear? Yes, sir. Yes. Sure. No questions for yes.
Arpit, just quick question. Can an event bus handle like millions of events? So you can see like there will be a lot
ingestion, yes. Event bus is meant to handle that.
Okay. So do you have just one event bus for like all Instagram users, like millions of Instagram users?
So there could be multiple event buses, but not for a or not for a closed set of use cases. You would typically want one event bus in your system. The scalability of event bus depends on the shards that it has, or in case of Kafka, the number of partitions that it has, because everything is hashed. So internally, one event bus is implemented by multiple queues. Okay, and you can add more and more partitions or more and more shards to your Kafka or your Kinesis. And when you do that, all the messages of a certain event would always flow into the same partition of it. Right. So, and basically that is how you get an ingestion scale on such architecture. Right. Now, where would you get consumption scale? So the parallelism of Kafka or Kinesis is limited by the number of partitions that it has. So let's say if your thing has just 10 partitions, so the number of concurrent reads that you can make on Kafka would be 10. And this goes for Kinesis. So Kinesis has shards. So if you have configured 10 shards, you can only run 10 consumers in parallel on Kinesis. Okay, so this is how, but it is meant to take in a lot of load. So depending on your use case, you would keep on increasing the number of partitions or the number of shards of your system or of your data stream. And this is how you would keep on attaining scale. So this is typically one queue for one event bus for one homogeneous set of events. But when organization becomes big, you might have like 4 or 5 major event buses, and then depending on architecture, you might want to have a few others. But typically all the major events are driven through like one homogeneous bus.
Arpit, even if the homogeneity is not there, like we can have different topics, right?
Yeah, exactly. You would have topics within that. Yeah. That so this does not mean that only one type of event would go in. So you might have different kind of topics that would there. So each of the event that is being published, it is one topic for Kafka. If you're talking about Kafka, like event, like photo published is one topic, user created is another topic, photo deleted is another topic. So all of these are topics within that.
And
So
like
these are,
and within topics, like this extractor, tag extractor, and image optimizer can work on one topic because they're consuming the same type of data.
correct. They can work on the same topic. Okay. So if you want to explore more into event-driven architectures, this is a great foundation to build upon. And there is a plethora of things that could be added. And Martin Kleppman and I think it's Martin Fowler who has written a very great article on event-driven architecture. You can go ahead and give it a read. So now basically coming back to the tags and the main problem at hand. How would our architecture now look like? Is our API server is upon publish would publish an event into this event bus. So wherever you from now on going forward, wherever you see this rectangle box with stripes on it, this is what our event bus would look like. So upon publish, this event is sent. Your tag extractor is subscribed to this event. So it would consume all the events for upon publish being sent or post publish being sent onto this event bus, and it would do the tag extraction thing and update the database. Like so, it uses text part of it from each post and then goes to the and extracts the tag and updates the database. So when post is published, API server publishes an event in an event bus, say Kafka, and tag extraction service reads the message on or the event from this bus. It processes the body, extracts the tags using regular expressions that we discussed, and it stores the tag in the database. Up till now, still we have not discussed about scaling database because that's where another bottleneck is. So our table was like photo ID and tag, which is definitely not optimal. So you would have to change it to photo ID and tag ID. So this is what the problem with our original tag design was. Our tag design had photo ID and tag, which is varchar. If it is a string, which means there is a lot of repetition. So tag hashtag sunset on 1 million photos would mean sunset be present in like a million times. Instead of that, storing a small integer is very, very efficient as compared to storing strings. And what's the worst part? If your database encoding is UTF-MB4 encoding, each character of the string is 4 bytes long and not 1 byte, which means it would make things even worse, right? So this is where you would have to keep in mind, okay, how would you, if your database is becoming a bottleneck, there are lots of basically there are lots of design calls that needs to be taken with respect to database design to optimize the flow around this. So a better way to do it is have a separate table called tags, which means you have photo ID and word ID, and another table called words. This means you'll have ID and word varchar. So hashtag sunset or any tag is not repeated in either places. The string is just placed at one place. The integer ID is being used as a reference. Although it adds one more join, but it gives a very solid database performance to you, right? So we make tags table smaller, which means better indexing, higher indexing in memory, gives you better performance, count queries become efficient, lookups become very efficient. So a lot of great benefits you get out of it. So over large amount of post and tags, we won't repeat the words. So no extravagant disk utilization on your database. Your database remains happy for a long time. Right? Now comes to the part. Now your tags are exploding. You have 2 million posts on Sunset, 300,000 posts on Vibe and whatnot. So given SQL table, if say you'd want to compute discounts, like storing number of photos per tag, computing this counts on SQL query is very expensive, right? You should not be doing that. Writing a SQL query to compute count on real time would add a lot of pressure to the database. But if you see on search and explore page or on any hashtags page, you would see the number of posts made on that. Right? So the number of posts made with that hashtag is some sort of thing, is a use case which is very common and very heavily consumed on Instagram or in general on a lot of other platforms. So a query like this becomes very inefficient. So what's a better way to do this? A better way to do this is having it pre-computed. So the query select count of photo ID from tags inner join words on tags.word ID equal to word.word ID, where words.word is equal to sunset. Like we have already made a join, that is okay, but doing that count on a big table is a little expensive. So this is something that is something that we have to be wary of. This is also going to explode number of photos per tag and all, very similar to the other use case. So once we hit the scale, right, we are getting 60 million tags per day, and all of this coming in like in a high amount of writes going into the database. So what do we do? So this is okay. Insertion on SQL. So this is another optimization that we can talk about. Like insertion on SQL tables are costly. It adds a lot of cost because insertion cannot happen without a disk write, because you can't have just an in-memory write being done there. So first fetch the word ID, then you make an entry into the tags table. So every write that you are making, right? So here with this kind of thing, when you're ingesting the tags here in the tags table, what you need, because with the tag extraction you have the words. Now these words needs to be converted into their corresponding integer IDs, right? So every write of yours is converted into a get as well. So given a word that whose entry you would want to make, you are also getting the integer ID of it, right, from the words table and then ingesting it. This would add a lot of pressure. So one way to optimize this is, instead of making one call for every write, you'd batch the tag ID. So you'd get like you'd batch it in the group of like 50 tags, or let's say 10 tags, and fetching the word ID and that word ID from it and using it in one shot. So instead of translating one write or one get for every write, you are just batching the operation to make it a batch insert, a batch get, and then a batch insert. So that's one optimization that you can do. So typically one optimization that people not really talk about is batch inserts. A lot of problem gets solved when you do insertion in batches. If you can do batch inserts, always do that. Don't have like loop main inserts. It doesn't do any good. So this is one way to solve the problem, but this is still not. So although this gives us a nice performance boost on the database, but it still does not solve the problem of scale. Although we are just trying to defer the scale exposure problem, but along the course we have just found a great set of database optimizations that we can do. So batch get and batch write would solve a lot of problem, but still explosion is there. So this is a classical case of like NoSQL database, right? So here, if you see, there is no relation between a lot of entities. So here what you see is, this is where you would have like photo ID comma tag is something which is unique. So this is not tag ID. So this is not word ID. This is like string tag. So what if we use a sharded database where we store? Now, what do we want? So if we see, what we're trying to optimize is the count of the post per data, or basically count of the post per tag. So the way we are storing the entries in the table is something that we are still okay, but we'll obviously optimize this. But at least let's tackle the case where we are storing where we are rendering the count of the post on the table. So what if we pre-compute it, right? So what if we pre-compute my entries of the tags and the count that we are seeing? So something like this. So let's say I have a sharded database, either Cassandra, DynamoDB, and whatnot. So I have my photo ID underscore tag is something which is unique. So because one tag could be present in one photo ID. So I might have DynamoDB or any key value store, which is sharded. And what I would do is, from event bus, when I'll get this information that on photo publish, my tag extraction would click. So this tag extraction service would extract the tags and have it stored onto a separate store, which is my tags store. The job of this tag store is to just store the tag. That is it. So for each tag, it stores some information. One of the information is the number of posts it has seen its presence, like doing count plus plus. So post count something. So every time for every event that it sees, it does a count plus plus for the tag. Right now, along with this, if you see the main page, so now you can, if you have a tag store specially meant for this, you can also piggyback a very interesting use case. Let's say on the tag page, you also see the top post of the tag. You typically see top 500 posts for the tag. So what do? You also store the popular photo IDs with that. So you might have a popularity service whose job is, for each tag, give me the most popular post for this tag. You'd get the post IDs and it would be stored in the tag store. This way, in this for each tag, what you are storing is you are storing the number of posts that that particular tag has been seen on, and the list of posts, or yeah, basically the list of most popular trending posts for that tag. So with this, the way we would render our tag page would be in order one, because given a tag, we would in one shot from the tag store get all the information that is required for us to render the page. So this would make serving count per tag an order one operation, and serving popular photos per tag becoming order one. Right. So the main tag page that is there, that becomes an order one page, because that anyway has to be lightning fast, and this makes it lightning fast. Got it? Clear?
Arpit, in this popularity service will also read it from event bus, but how would popularity service know that these are the tags published as of now? So it also has to read from event bus, right?
Yes. Exactly. Great catch. Great catch. Right? Because popularity service now also needs to know key, these are the tags on which I got something. So popularity service might do a batch processing of it, might fetch a lot of things in batch key. Okay, this is basically, these are the posts that on which I've seen something happening in last 5 minutes. So let me recompute popularity of it. So you might have a different popularity algorithm which sees key how many reactions each tag is getting, and depending on that, you would just run small aggregations. So that is a different algorithm altogether, which I can talk about an hour about it. How do we design a popularity service? We will anyway have a small discussion about it in next week. Next week. So how do we do that? So a popularity service also needs to know a great catch. So either it could be a cron that runs every 5 minutes or every hour, that computes popular tags for all the tags possible, or for all trending tags, something like that. It would pull the data either from event bus to, for every tag, I'd need to run popularity service or update some count around it. For example, let's say hashtag sunset tag is trending. How would my popularity service also know that this tag is trending? Right? So it would also be consuming events from the event bus, and this is where event bus actually comes in very handy. If we would have done using multiple message brokers, a lot of repeated messages would have been there. Right? So n entries would have been there. Here, anyone would just come in and just start consuming data from event bus, and then compute popular photos per tag and update it in the tag store.
It's similar to what silver medal you want, like in 1 hour there was so many tweets, and then
yes. Yes. Okay. Any concern or any issue here? Any questions here? Okay. So let me pitch this one thing. So here although we build a tag store to do count plus plus and tags wala thing. Now, how would you protect your database? So let's say we are into SQL, and in SQL we had this tags where we had photo ID and tag ID, right? How would you store? Because we never discussed, we are almost done, but we never discussed this part where how would you scale up your system, or how would you scale up your explosion of tags and photos ka combination? How will you store that part? Let's brainstorm around it for 5 minutes. How will you design this? because SQL table will die off, because at this scale your SQL might like your one single your singular SQL server would cry off. How would you scale that thing?
You shard by the tag ID.
Shard by what? Tag ID. Why tag ID?
Shared by country also can happen.
Typically I can still see Thailand's Instagram feed. Like, why not? Why would you want to have shard by country ID? Because hashtag is hashtag. Like, shard by tag ID is a great answer, but why just tag ID?
Because your lookups are by the tag. Not by the photo. Your input is the tag. You want to get the count per tag and you want to get the photos per tag. So that's the only input. So no need to factor the photo ID in the input.
Perfect. Well, just one concern here. So here, are you using SQL database or NoSQL?
NoSQL.
Okay. To do this, you are using NoSQL database. But now, if you see with respect to the tags thing, we would still need a source of truth, right? So here in this design, the tag store that we have, here we have count and popular photos. So popular photos could be just 500. What if I would want to see all photos for this? So that has to come from the source of truth. How would you design a source of truth for photos and tag mapping? Right, because that is where the explosion happened, right? Because your SQL might not take up those many writes. So how will you handle that? So you have already sharded your database. Now what would you do?
Now get all the photos for a particular tag, right? That is what is a requirement, right? So for particular tag ID, get all the photos.
For a particular tag ID, get all the photos. Which database would you pick? Which database? So you said NoSQL, but in NoSQL, I just can't pick any NoSQL database. There are just a specific NoSQL which would solve this very problem.
Document, maybe Mongo.
Okay.
Cassandra would be good, I guess.
So first see, this is where the basically this is where the discussion should spark. Look, so when Mongo came in, people came in. So MongoDB is one, but Mongo se better is Cassandra. Why?
The column families are all stored together in the same. So things like aggregate and things like that. It's very easy. It's very optimized for aggregate queries. Like if you want to find the count of, because the attributes are stored together. That's what you want. So things like query by tag or something like that. That is a single, that read becomes very efficient fast.
Correct. So reads and aggregates are really fast. It's meant for that. So if you don't know, you should all be aware of like the advantages of each and every database, like why, which kind of problem does it solve, right? So MongoDB does great job, not with aggregation, but it does a great job. Like so MongoDB is the natural progression from SQL world to NoSQL world. But even in NoSQL world, when you have document-based databases, there are other databases which outperforms a lot of things. So a lot of use cases. Another great thing that you can use is DynamoDB. Because with DynamoDB, what you can do is you can build your tag store on DynamoDB, because DynamoDB requires one hash key and one range key, right? So hash key is, so your hash key would be your tag ID or your tag, your string tag, right? Because it would not matter for DynamoDB if it's a string or an integer. And your range key would be created at. Right. So with this, now what you can do it is you can actually scan through the table, because by doing or by storing this in distributed way, we have solved, since your DynamoDB or Cassandra or MongoDB is sharded, it's distributed. So you have solved the problem of data explosion so that one node does not become the bottleneck. The request for one tag will always go to one shard. That is done. All photos or all tag to photo mapping is stored in one instance for a certain tag, that is cleared off. Now iteration to do that, like, so typically you would want to iterate on for each tag. I would want to get all photos in descending order or within a certain time range. Why to do? Because this was the core basically this was a special index which we created in the SQL design on created at, right? Because we wanted to get key when was this photo published, or now with this created at pay index or ordered by created at, what we are actually getting is we are getting this benefit where we would see key we can have this filter key. I want to process all the image or all the photos, because to this will help you for your popularity service. Let's say popularity service says that I'd run every hour, I'd pick all the photos being generated for a certain tag in 1 hour and do some analysis on that. So this query would be very well supported when I have this sort of schema, right? Where I am sharding by tag ID, or I'm sharding by tag, and I'm sorting by created at. So DynamoDB also becomes a very good choice here, because your hash key could be your tag, and your range key could be your created at. So if you'd want to go through all the photos for a certain tag, like tag photo mapping, you can do this with this, and a separate tag store which you have, where given this tag ID, I would want only the popular photos and the count to render the tag page. You can use this tag store. Right, so so if you'd want to scale up your photo tag, if you'd want to solve the problem of your photo and tag wala problem of data explosion, you would shard it with tag ID and have created that as your sorting parameter. Right, so this way you can also go through all the posts sequentially from now till epoch, all the photos for a certain tag that were ever published on that. This could be very well used by a popularity service as well. Questions? Yeah, sure. Say yeah. So an interesting challenge. So make this architecture cost efficient. Try to relax some constraints. Like one small hint, what makes this challenging or this thing problematic, a little problematic, is doing count plus plus. Right? Not on every photo published you would want to do that. Like, can you make this thing a little cost efficient? Think about that. There is a lot of great things that you can do, but do brainstorm around this, because while doing this, while making this cost efficient, we would first need to understand what's making this architecture cost inefficient, and then solve that problem. Right? You'd have to put some thought around re-architecting this stuff. By hint was relax some constraints, and that's one of the constraints is doing count plus plus. So you can think around these lines and try to just brainstorm around it. This is a great challenge to have, because like Unacademy saved 60% of money by doing this FYI. So it helps you save a ton of money. Right. Another one is try modeling reactions. So reactions we already discussed, like how would we do, like 2 ways to do it. But user on photo, like, share, and other reactions, if you'd want to do it, actually go ahead and implement it both the things. Like at least do it on SQL side using enums and all. You'll see the kind of benefits you would get. Atomicity you would want to implement, run a load test and do that. So this is very similar to tags, but try to model reactions around it. This is an interesting problem, and obviously this is, and scaling it. The problem at scale, because reactions also explode, because the maximum cardinality of reactions would be number of users multiplied by number of photos, right? So similar to tags, reactions would also explode. So this is something that would draw inspirations from your tags design, and you can design something very similar with reactions. Okay, so you can definitely implement this. So yeah, that concludes the first part of social networks. Any question?
I mean, I just thought of a design. Maybe can you let me know? I mean, can you go to the previous one, the challenge, making it cost efficient? Is it the account plus batching, micro batching stream processing, basically, instead of doing it on everything, you can actually, I mean, batch, I mean, put I mean, basically group them into another topic, which actually streams the process and, I mean, streams it.
Let others brainstorm now. Varun. we can definitely discuss it tomorrow the first thing, but I would really want people to like actually think about it. कि क्या कर सकते हैं. Like, that's why. But yeah, you are on track, and there are 3 other things that you can do on this. If you just relax some constraints, like what constraint are you trying to relax, and what kind of system or what kind of architecture would you choose to which would be optimal for those things. Like basically considering that constraint is now relaxed, what would you choose? So that part. So there are at least three that I know of. There could be several others, but 3 is something that I know of. But you are definitely on track with that.
Yeah, writes are pretty costly on the DB.
Correct. Like, so for every post published, you're doing count plus, making one atomic call. That's costly. That's going to make your database bottleneck. So what kind of constraint are we losing on, or basically what kind of constraint are we making a little lenient, and what kind of performance benefit are we getting, and obviously cost also. Let's think about that. We'll if time permits, we'll discuss it tomorrow. Yeah, Rona?
Arpit, you shared 2 things like in reactions. One was like you are updating based on like 0 for post for like, and second like 1 was for this and that thing. So that works in Facebook. But
Yeah,
in
that would
Slack,
work here. Yeah.
But in Slack, you will see many reactions can happen on a single.
Nice. Great thing. Huh? What about Slack? Let's just add that. What about
But
Slack?
Arpit, the design, you told that we can have different fields. Let's say I create a new emoji on Slack and have a new. So would I add another field in table? That would be not be efficient. Right? So how do Slack goes for reactions?
Think about it. Nah, it's really not hard of a problem to solve. What would you do if you cannot add columns? What's your another approach? If you cannot add column for every new reaction that is there, what would you do? What does a normal
Just
SQL
add
design
multiple
suggest you?
rows. Yeah.
Add multiple rows. Exactly. Just add multiple rows, no?
But that would also like entries will like exponentially increase. Right?
Yeah,
Like if
exactly. That's the problem. And the way you would be solving that problem is distributed sharding. Right. So as an optimization, you can typically that's how you would think. Like Slack, by the way, thanks for bringing it up. Like that's a great thing, because in Slack you can give multiple reactions to it. So instead of replacing the same thing again and again, you would want to store all the reactions that a user gave. And a user can give hundreds of reactions. Right. So typically, either if you're doing a pure 3NF SQL design, you would store each reaction of the user as a separate row, because you cannot have columns, those many columns. If you have fixed number of columns, if you know that there are fixed set of reactions that you can go for, you can add it as rows. Sorry, you can add it as columns. But if these are dynamic, as you rightly said with Slack, you can add custom emojis, give custom reactions. Each of them has to be a row if it's a pure design on 3NF. If it's a NoSQL-ish design, you can skip all of that and just have a list of reaction IDs, something like which gives like emoji IDs, something like that. Right? But if you can just add it, and you are taking a hit, so you are making things denormalized and adding thing in just one JSON document, like something like this. Let's say your post is your post ID is this, and then you would have reactions. So this reactions would be specific to the user who has made the call, so that you would no. So let's say these are all the reactions on the post. So these would be all emojis and the count of it. And let's say you would have user reactions. जिसमें you can just store it as one array of like what all emojis like smile and laugh or something like that, stored in just one place. So instead of having it as multiple rows, if it was pure SQL design, you can do it as multiple rows in your reactions table. But if you would want to have it completely denormalized, you can do something like this, like store it as an array of like, just assuming that people not creating 1 million reactions, like that's not feasible, right? You would have a hard limit on that. You can only make like 100 reactions per post, which would limit the document size.
And every time I like, let's say we have a cron job that like extract reaction in every one, let's say, and if I go to a thread and add one more reaction, so what it will do is read it and then
read it and then update it. Yeah, but I've very heavily used DynamoDB, so I can comment on that. So you don't really have to read and update. This is even possible with MongoDB. You can direct do array manipulations. So list manipulations. You can say that delete or basically remove from this list. If array is something which is natively supported by the database, let's say Mongo supports it, DynamoDB supports it, you can make array manipulations there. You can say add this to array, remove this from array.
So you don't need to update the whole
yeah, you don't have to read everything and then update and then put it back. You can just do that thing atomically, add and remove from array.
Right, but for that also, like in short, you have to read it once. Like array, you have to read it. Like how do you know that this is there? This reaction is there.
The first time when you're getting the post to the client, that's when you're reading it.
Right. One time you have to anyway read.
You would anyway have to read it because that's when because that is how you would be rendering it on the UI, no?
Yes.
Right. But then when you choose to react or undo your react, for those calls, you don't really have to do it, because for those calls, your API server does not have to read back the post, because you can directly do array manipulations. Right. So two cases, if you are having a pure relational design, then you would have store it as rows instead of going by columns. And here you can have what do you get? Nested array. You would have arrays and then use insert or delete directly on it.
In that case, you will hit the document every again, or like it will be a cron job or like storing in immediately.
No, every time, because it has to be source of truth updation. No? You will have to update the document in real time. So it would still be write heavy, but the writes would happen on a certain chart for that certain post. So if a lot of people are updating on the post, then thoda problem hoga. But array operations would be atomic by default on a chart. So by default atomicity hoti hai, so that would not cause any problem.
But like for some period of time only, it will be write heavy.
Might some edge case or something. Yeah. So see, these were non-relational databases kick in like very fancily, like just store a reaction in array, because you would not store like every reaction as a separate document in a NoSQL storage. Like you can have this leverage. Okay, you are just piggybacking all the reactions in one place because it's non-relational.
Right, right. So I haven't worked in NoSQL, so I was thinking that every time the document will get updated. But you told that array can also be updated. Like one field can also be updated in a.
Yes, basically basically partial updates to a document can happen. You don't always have to do full document replacement every time.
Thank you.
Yeah, thanks for bringing this up. Sorry. Any other question? No, thanks. And basically, this is why I love CBCs. Like, see, since if it was not a code-based course, we would have never discussed LACTA, this stage where multiple reactions are given. Like, basically, thanks for bringing it up, Rana. Chalo. Thanks guys for joining in. Tomorrow we'll cover the second half of social networks. A lot of interesting designs are planned there. Photo tagging, scaling, two very interesting stuff. You anyway have the agenda. What I'll be doing is I'll be uploading the video on again the portal. I'll drop you an email around that, and I'll drop a message on Discord as well. So So see you guys tomorrow at 4. Thanks. Bye bye.
Bye, folks.